Okay, lesson 96 is about estimating angle measures and also about a different concept called the distributive property with algebraic terms. Now, the first thing we're going to do is use a mental image of a clock face to assist us when estimating measures of angles. And you know that a clock is a full circle. So if we were to divide our clock into four quadrants, the angle that's made by that first quadrant, you know, is a 90-degree angle. The angle right here would also be 90 degrees, the angle here, and a full revolution around the circle is 360 degrees. So if we had an angle that's coming right through the middle of here, we know that would be about a 45-degree angle. But we can use the clock face to help us kind of build a mental image, okay, of how much each little tick mark on the clock would be. So from the minute mark to the next on the face of a clock, if you take each, so how many minutes do we have going all the way around? We have 60 minutes. If we divide 360 divided by 60 minutes, okay, we get 6 degrees. So 360 degrees would divide into 6 degrees. So that means each little tick mark on a clock would be about 6 degrees. So if you're down here at the 2, okay, then you've gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 6. So an angle that goes right about to there would be about 60 degrees, okay? What the book has you doing is looking at a figure like this and estimating certain angle measures based on mentally putting this image onto a clock face, okay? So the first thing you're supposed to do is estimate the measures of the figure. Next, you're supposed to use a protractor to actually measure and see how the actual measures of these angles and to see how much different your measures are from the actual measure. So what the book has is a great image that I'm not going to recreate. I think you can just look in the book on page 658 of this figure transposed onto the clock. And, well, I guess I could kind of write it for you guys. Let me erase some of these extra marks. And let's see if I can draw it on here for you so we can talk about it. All right, so if we're using this image, it looks like it goes through the center from here to about here. This one goes to about 2 there, and this one would go up here through 12. Okay, so if you kind of look at this, then this is D, this is O, this is A, and it's right here would be B, and this up here would be C. And what it's asking you to do is kind of look and say, well, what does it look like angle COB would measure? COB would measure, that's 5, 10, about 11, 12 times 6, okay? So roughly, okay, 72 degrees. And if we estimated at that and then actually measure, we'll see that our measure, it really is around 75 degrees. So it's a really close estimate. So I think you guys get the idea. You need to just kind of have some sort of a mental image for estimating angles. Also, so when you're measuring them, that you won't be way, way off on your measure. If you can kind of mentally estimate an angle and then you measure it, if you estimated it to be 60 and your measurement says, 85, something might be wrong. So you need to kind of pay attention to that as you're estimating. All right, the last concept in this lesson is about the distributive property, which you've done before using numbers, but now we're going to do it using algebraic terms. So if I have A times B plus C, okay, I can distribute the A across both of these terms. And what I get is A times B plus A times C. A times B plus A times C. Okay? It's frequently used in algebra to simplify expressions and to solve. So if I have something like 2 times x minus 3, all I'm going to do is take that 2 and distribute it to both of these terms. 2 times x would give me 2x. 2, remember the sign goes with the term, 2 times negative 3 would give me negative 6. Right, so that would be the answer to that one. The other examples you go through are negative 2 times x plus 3. Okay, again, distribute the negative 2 to both terms. Don't forget to keep the sign with what you're doing. So that'd be negative 2x, and negative 2 times a positive 3 would be negative 6. Okay. The next one was negative 2x times x, or I'm sorry, negative 2 times x minus 3. Okay, we're going to distribute our negative 2. So negative 2 times x would be negative 2x. Negative 2 times negative 3, and negative times a negative would give me a positive 6. So the tricky part with these is truly just going to be keeping your signs straight. The multiplication's easy. I know you guys know how to do that. Now, the next example is when you don't have a number, but you have a variable at the beginning. So you have x times x minus 3. What is x times x? Remember, it's not 2x. It's x squared. Okay? X times x equals x squared. And then x times negative 3 would be negative 3x. All right? We're going to have now problems where you have to use this property to simplify within an expression. So if I have x squared plus 2x plus 3 times x minus 2, okay, I'm going to leave my x squared alone, leave the 2x alone. We've got to deal with simplifying within parentheses and getting rid of these parentheses before we can do further simplification. So 3 times x would be positive 3x. 3 times negative 2 would be negative 6. Now what we have to do, are there any like terms that we can gather together? Are there any more x squares? Nope. Let's write x squares. Are there any more x's? Yep. So 2x plus 3x, positive 5x, and then negative 6. So that would be the simplification of that expression. Okay. For the lesson practice, there's just some estimating to do on a clock face. Okay. I'm going to let you guys work on those. And then some simplification that I really think you guys will get these, but what I'm going to do is I'm going to go ahead and write the answers to these on the board. Okay. So for H, you should pause and try to do them. Okay. X times x minus y. Okay. I is negative 3 times 2x minus 1. J is negative x times x minus 2. K is negative 2, 4 minus 3x. L, x squared plus 2x minus 3 times x plus 2. Okay, and then m, x squared minus 2x minus 3 times x minus 2. Okay, I want you guys to try to do those on your own before you look at the answers. So the answers for these, this would be x squared minus xy. Okay, just distributing that over. And you can write these little lines if it helps you. This would be negative 6x plus 3. So negative 3 times 2x would be negative 6x. Negative 3 times negative 1 would be positive 3. This one would be negative x squared plus 2x. Okay, because negative x times x would be negative x squared. Negative x times negative 2 would give me positive 2x. This would be negative 8 plus 6x. This one you're going to have to do in a couple of different steps. You have x squared plus 2x minus, so here you have to do this part, which would give you minus 3x minus 6. Okay, so you'd have x squared plus 2x minus 3x minus 6. And I'm going to write the answer out here. The answer would be x squared, 2x minus 3x would be negative x, and then negative 6. And then the last one, again, you have x squared minus 2x, negative 3x, negative 6. Okay? Then you're going to take your x squared. There's no other like terms for that, so you just leave that alone. Negative 2x and negative 3x you can combine, and you would get negative 5x minus 6. Okay? Oh, did I do something wrong? I think I did. Yes, right here. Negative, this would be negative 3x. Negative 3 times negative 2 would be a positive 6. So that should be a positive 6. Let me check all my answers, make sure I didn't do something wrong along the way. That's right. Yep, all set. Okay. You guys have any questions, bring them to me when we talk during the week. Thanks.